All right.
We'll take care of that, Steve.
Thank you. Okay, well, welcome everybody to Making Measurement Matter, a practical guide for assessment directors and test users. Let me just move this, here we go. This webinar is sponsored by the Special Interest Group for State and Local Assessment Directors from the National Council on Measurement and Education. For those of you who don't know about NCME, you can go to our website, ncme.org, and you can learn all sorts of things like how to join. And NCME is probably most famous for being one of the co-authors of the Standards for Educational and Psychological Testing, which you see pictured here. And if you look real hard, you'll see us way down at the bottom. We're the last of the 3 professional organizations that have come together to develop these. The workshop is going to be presented over 3 days. We figured people are too busy to have 3 hours to devote to a workshop. So we have 1 hour today, 1 hour tomorrow, and 1 hour on Wednesday. So I'll be giving part 1, some fundamentals of educational measurement, and I'm at the University of Massachusetts. I'm actually about 6 miles away from there in Northampton. And this is what I looked like when the barbershops were still open. Part 2 will be delivered tomorrow by Vince Vergis, my colleague from the Florida Department of Education. And Vince will be talking about administering large-scale assessments with fidelity. And then we'll conclude on Wednesday with part 3 with Art Thacker from Humro, who's going to be talking about communicating the results from educational tests to the public and policymakers and so forth. So what I'm going to talk about today is just a basic overview of some of the fundamentals involved in educational testing. We'll talk about types of tests, some of the purposes. I'm going to cover some of the standards for teacher competence in educational assessment, because I think it gives us a nice framework for, what are the basics that people need to know to really interact and be successful in helping educational tests be effective. 2 things that I think are real important. One is norm reference and criterion reference testing. If people don't understand the difference between those, and they're very often confused, it can create some problems. And then also just some fundamentals about reliability and validity. If we have some time, we'll also talk about some fairness issues. And I just want to thank Art, Vince, and Darren for helping me decide what these topics would be. It's going to be a little bit fast, but we will post this video, and you can view it once it's posted and slow it down if you want. If you do have a question, post it in the chat, and then we'll look at those afterwards and either address them over the next 2 days or in some other venue. I want to start by just reminding people that not everybody loves educational tests. I mean, we can lose sight of that because we love our field and we love working on them and so forth. So I took this picture from a study done by Wheelock, Bevel, and Haney back in 2000, where they had students drawing themselves take the MCAS, which is the statewide test in Massachusetts. And this is my particular favorite. We've got the student drawing himself falling asleep on his desk while he's drooling on the test booklet, dreaming of the school burning down, and we've got a don't test protest sign, and this little picture here is his mother yelling at him with the score report. So just keep in mind, we are all working in a noble profession, but at the same time, we know that there's not a lot of love out there for educational tests. So with that in mind, let's talk about what are the types of tests that are out there. This could be a long list, longer than we have here, but just to get some kind of general framework, there are classroom assessments, which kids take all the time. And then we have the standardized achievement tests from kindergarten through high school that many students experience, all public school students in the United States are experiencing at least annually. There are formative assessments that teachers use to check on students' learning and adjust their instruction. Then there are admissions tests, which are always in the news, things like the SAT, the ACT, the GMAT, the LSAT, pick your profession. There's probably some type of admissions test. A lot of English proficiency tests that goes on. Licensure and certification testing, any type of credential. We've got the advanced placement test. We have tests used in employment. There are intelligence tests used for screening in schools and so forth. International baccalaureate. So lots and lots of tests that are going on right now. And when we think about all these tests, there are really like 2 worlds of testing. On the one hand, we've got classroom assessments that are, impact millions of kids every week. Teachers are giving them, and they're critically important for a quality education. And then we've got the standardized testing. Most kids will experience annually or biannually, and the standardized tests tend to be more misunderstood, which is unfortunate because it limits their utility, which is one of the reasons why we're going over these fundamentals today, to try and do away with or limit those misunderstandings. And we know that standardized tests are mistrusted by many people. If you want to get on the front page of the New York Times or your local paper, come up with a nice criticism of a test, or find a flaw in a test, and the press will love that. On the other hand, tests can also be over-trusted by some. So one of the things we worry about are tests being used for purposes other than for which they were designed, or for tests being used for multiple purposes that really stretch what they're valid for. So because we've got these two different worlds and all this mistrust, we kind of have these communication problems in educational testing. We know the psychometric community has had little impact on classroom assessment, but at the same time, we know classroom assessments are going on all the time and impacting millions of kids. We also know that many K-12 teachers have insufficient knowledge of standardized tests, some of the fundamentals we're going to go over today. And it's the same with many K-12 administrators. And the policymakers are not exempt from this either. Although there are some that really have a good idea of the utility of tests and the limitations of tests, there are many who do not. So in thinking about how we communicate the fundamental principles of testing, I think will really help to resolve this problem. So one of the things we need is a common ground with respect to some key terms, one of the most important of which is a standardized test. So if you think for a minute, what does standardized testing mean? What does the word standardized mean with respect to testing? If you want to type some answers into the chat, that would be fine. And if we had a bit more time, I would invite you all to have a discussion about what standardized means. But let me just jump to the answer, because with respect to standardized testing, what we mean by standardized is, first of all, uniform content. Everyone is tested with the same content. Also, we have uniform test administration conditions. Everyone's tested in the same conditions. And the third element of standardization is uniform scoring. So everyone scored the same on the same content in the same conditions. So the idea is actually to promote fairness so that everyone is kind of competing on a level playing field. So keep everything the same for everybody. What standardized doesn't mean is that it's a multiple choice test, or it's only a testing lower order skills. Think about the GRE or the AP exams, for example. They're certainly standardized. Doesn't mean we can't have performance assessment. It doesn't mean it's a bias test. And it doesn't mean we should automatically be against it. You might say, Steve, why do you have that on the screen? Well, a lot of people hear standardized and I think, well, that's bad for education. But from what we just saw, standardized just means we're trying to keep the conditions the same for everybody. Now, we know sometimes we have to adjust those conditions or make them as flexible as possible, but the idea is really to provide a level playing field for everybody. In more advanced versions of these webinars, we could talk about test accommodations and some other ways we try and adjust these standardized procedures. But the basic idea is to let everyone know the content they're going to be tested on, deliver that content in the same way for everybody, and score it in the same way for everybody. Those are the goals of standardization. And assessment is important in the educational process. So at NCME, we believe that educational assessments play a critical role in improving instruction and in quality instruction. And this curriculum, instruction, assessment triangle kind of illustrates the role of assessment is not separate from it, but rather it should all be aligned and integrated together. So states put forward a curriculum frameworks that are adapted at the district level to be implemented in the way they see fit, and the teachers adapt that for their instruction. So the instruction should be tied to the intended curriculum. And of course, the assessment needs to be measuring that curriculum and should be also measuring the instruction. If these three components are all aligned, then we know assessments are going to be able to facilitate instruction. So if we think about teachers, the key part of that triangle, the lower left part, we know job analysis of what teachers do indicate they spend up to a third of their time dealing with tests, developing their own tests, scoring their tests, preparing for the standardized tests that they're administered in their state or district, then administering the tests, interpreting the results of the test, communicating the results. So teachers are intimately involved with testing, as are principals and other administrators, and many of you on this call. So we have this gap between the people who really are trained to develop and understand the strengths and the limitations of tests, and then those who are doing all these testing. So we feel like we need to bridge this gap between the psychometric community, teachers, educational policymakers, and others, to provide a better understanding of appropriate test development, appropriate test use, and the value of the information that tests provide, how to interpret test scores, and also what are the limitations of testing. So to bridge this gap, we need a better understanding of essentially the practical constraints on large-scale testing and some of the technical aspects of testing. The way I look at it, we kind of need like a food pyramid. If you look at the food pyramid from the FDA, we see that there's a lot of complex scientific information that's put into this one picture, and the public gets it. Not many fats, oils, and sweets, and more vegetables and things like that. Or maybe it's a food plate now. But the point is, we need to better communicate the fundamentals and the limitations of testing to important lay audiences in a way that's not confusing. And that's one of the goals today, to start that process. So if some of the fundamentals we go over today, even if it's really basic for you, if you could take that and share that with your colleagues and your constituents and parents and teachers in the field, it'll really be helpful. And also let us know how NCME can do more to help communicate that. Now, one example of an attempt to bridge classroom and standardized assessment is formative assessment. And here you see a description of what it is from the Council of Chief State School Officers, FAST-SCAS. And it describes formative assessment as a process used by teachers and students during instruction that provides feedback to adjust ongoing teaching and learning to improve students' achievement. So if you think of that curriculum assessment instruction triangle, now we've got the instruction and the assessment going just directly hand in hand, almost simultaneously in formative assessment. And one of the things NCME has done to reinforce this bridge, or to build the bridge, is the Classroom Assessment Task Force that's been alive for about 5 years now. I'll invite you to visit some of the accomplishments and future activities of this task force on the NCME website. Here you see a picture of some of the task force members. They've had 3 conferences so far that have been very successful, really focusing on what teachers are doing in the classroom. I just want to talk a little bit about the purposes of educational tests, and the first few slides here come from the Standards for Educational and Psychological Testing that NCME is a part of. You see it in the lower left-hand corner there. So if we think, what are the purposes of educational tests? Well, one of the things the standards say is to, I'm sorry, one second. Is to make inferences about students. So inferences that are going to inform teaching and learning at the individual level or at the level of developing curriculum, make inferences about outcomes for individual students or groups of students, and then inform decisions about students, such as certifying mastery of knowledge and skills, promotion, graduation, placement in instructional programs. So the theme here is providing valid information. Sometimes that information can be used to grade students, to monitor student progress, to provide feedback to students and to parents. If we go outside of the standards and think about some of the other purposes of tests, we know they're used for accountability and evaluation, such as the statewide achievement test used in NCLB, or which is now ESSA. The National Assessment of Educational Progress, the nation's report card, district-wide testing, evaluating teachers in schools and school districts and so forth. So they're used for lots and lots of purposes. Later in this workshop, we're going to talk about validity evidence for these purposes, because we don't want tests to be used for purposes for which they're not valid. And some of these on the list might fall into that category. What else are they used for? Diagnostic purposes, right? To diagnose student strengths and weaknesses. For those of you out there who have children who might have a disability, learning disability, you know how important the diagnostic assessments are. Then there are medical and psychological diagnoses, language proficiency tests. There's also the purpose of prediction. We talked about selection tests, and there's employment tests, there's tests in the military. So a lot of these tests are trying to identify students or examinees for particular programs. We also use tests for research, in longitudinal studies, international comparisons of achievement, cross-cultural research. And some of you might be thinking of other purposes for which tests are used. So what kind of questions do we have and what do we need to know about how we can help tests fulfill these purposes? Because of these questions, and we don't have time to really have an interactive dialogue on it, I'm going way back, I can't believe it's 30 years, but to the standards for teacher competence in the educational assessment of students. This was NCME's effort where they collaborated with the American Federations of Teachers and the National Education Association, so the two largest teacher associations, to develop what are some of the standards that teachers should know about tests. There's only 7 standards, so I'm going to go through them quickly. And the reason I'm going through them, I don't think they're just limited to teachers. I think they're important for anyone working in education right now. And NCME and the NEA and AFT developed them because there's a potential for student assessments to be fully realized, in that student assessment is believed to be an essential part of teaching, and good teaching cannot exist without good assessment. So the 7 standards, one has to do with just teachers should be skilled in choosing assessment methods. And again, it says teachers, but you could think about district coordinators and school coordinators and state people and so forth. Teachers should also be skilled in developing assessment. And now we're going back to the formative assessments and the classroom assessments in that area. Teachers should also be skilled in administering, scoring, and interpreting the results from the tests they develop and the ones that come from outside. None of the assessment makes sense if the results are not going to be used and used appropriately. So teachers also need to be skilled in using assessment results. Teachers should be skilled in developing grading procedures that might use assessments, and you can see the datedness of this now by the word pupil. You don't see that very much anymore. And also, teachers and others should be skilled in communicating assessment results to students, parents, other lay audiences, and colleagues. And finally, it's important to recognize appropriate and inappropriate testing practices, unethical, illegal, and other standards and laws associated with testing. So with these kind of 7 fundamental competencies in mind, we started to put together some of what we're going to talk about today, tomorrow, and Wednesday. Now, these are pretty old. I said they're 30 years old. One thing that's interesting to note that they don't have that I think is important for teachers and others is preparing students to take tests. So there's a really important need for guidance in this area, more than just get a good night's sleep and eat a good breakfast, but rather having students practice taking tests and understanding what's going to be on the test and so forth. So that's something else we'd like to see some progress in. Susan Brookhart, one of our colleagues, realized how old these were and got tired, I think, of waiting for us to revise them. So she called for an update on these standards and actually did update them. And this was published in 2011 in the journal Educational Measurement Issues in Practice. This is an NCME journal. For those of you on the call who are NCME members, you can go to the website, log in, and download this article for free. But basically, she said teachers need to understand the content and performance standards in the state, which was a big change from when NCME developed these in the 1990s. So Dr. Brookhart's work is an important improvement on these standards that I just referenced. So you can go to the NCME website and grab this. You can Google standards for teacher competence and get a lot more of what I've been reviewing very quickly. Okay, so one of the most important topics, I think, is just getting a good idea of what the difference between norm-referenced and criterion-referenced testing is. Most educational tests can be classified into one of these two areas. And in my generation growing up, everything was norm-referenced testing, and we'll talk about what that is in a minute. But now most of our world is criterion-referenced, but people still think of educational tests as norm-referenced. So that's just a little prelude into what we're going to talk about. So norm-referenced interpretations, norm-referenced testing, describe the performance of a student on a test, the performance of an examinee on a test in relation to the performance of other people who took the same test. So the group to which the students are compared is called the norm group. And I always think of, when I hear norm, I think of like the average person, the average guy. I actually think of Cheers. Remember Norm and Cliff, who would sit at the bar in Boston, just these average guys. So that's the norm group. So for example, you might get a test score result. Well, Carla scored at the 60th percentile on the ITBS math subtest. What that means is that Carla, her performance, her score was equal to or better than 60% of the students in the norm group. So that's a typical way we interpret the results of a norm reference test. It's how well did someone do compared to everybody else? So things like percentiles are a very common way to report the results of norm reference tests. So if we have a clearly defined norm group, norm reference test scores indicate how a person's skills rank relative to others who are also tested. So the way these tests are built is basically to line everybody up and differentiate amongst themselves as much as they can. So tests like the Iowa test of basic skills or the Terra Nova tests are built to kind of maximize that variability. And the idea is to cover a large domain of content, 8th grade math, for example, but not in great depth, so that we're covering a large amount of the domain so we could spread people out as much as possible and kind of compare them. So if you see things like percentile rank scores or grade equivalent scores, normal curve equivalents, z-scores, Stanines, these are all scores that really represent the relative position of the student in that norm group. So if you're at the 90th percentile on a test, then you have performed as good or better than 90% of the people who are in that norm group. If you're at the 10th percentile, you scored as good or better than 10% of the people. If you have a grade equivalent score of 5.1, that means you scored as well as the average 5th grader during the first month of school. So the referencing of the information of these scores is related to the average performance and the distribution of performance of the norm group. Criterion reference tests are very different. It doesn't matter how other people performed. It's all about how well you performed, how well the student performed with respect to some criterion of content, some achievement level, for example. So criterion reference tests describe what a student can and cannot do with respect to a well-defined domain of knowledge or skill. So now think about all the testing we're doing in association to No Child Left Behind or ESSA. You know, basic, proficient, advanced. These are criterion referenced standards in that all students can reach proficient. It doesn't matter how some other student did, it doesn't affect your performance. You're judged with respect to that criterion of performance. So student scores on criterion reference assessments are interpreted in terms of mastery or proficiency of this defined domain. So one example might be Alvaro demonstrated mastery of solving algebraic equations, or Maria is advanced in 8th grade reading in Massachusetts. In these examples, it doesn't matter how well Maria's or Alvaro's colleagues did. Each individual is judged with respect to a predefined level of performance. So in criterion reference testing, typically the student's performance is evaluated with respect to some standard. These standards are typically established by subject matter experts who in K-12 tend to be actual teachers who are teaching in that subject area. In licensure and certification, they would be practitioners who are already licensed. Basically, they'll look at the test and they'll think about what competence means, or in K-12, they'll think about what proficiency means, or what approaching expectations and those different kinds of standards mean. And based on what's being measured on the test and what those expectations state, they'll set cut points on the test to help classify students into those categories. So again, the big difference between criterion reference and norm reference is whether you're being compared to others or whether each child is being compared to a standard of performance. So criterion reference interpretations, excuse me, involve test scores being interpreted with respect to a specific domain of content and the performance standards associated with that content. One thing that makes these interpretations helpful are descriptions of the performance and even sample items. Like students who are at this level can answer these items without any trouble. So criterion reference interpretations require a clearly defined domain of content. They tell what students can and cannot do. You might see a profile of the skills that students have mastered or have not mastered. And the items are directly relevant to the learning outcomes. So differentiating between students is not important, but trying to identify what the students know and do not know is important. So one of the differences between norm reference and criterion reference tests from a test development perspective is that on a norm reference test, very easy or very hard items might not make it on there because they don't differentiate people very much. But item difficulty isn't as much of a concern on a criterion reference test because the content of the test, what students need to know needs to be measured. Some of that might be easy and some of it might be hard, but we need to know if the students have mastered those aspects of the content. I mentioned before, criterion reference tests are typically expressed relative to standards of performance. You know, what might define proficiency? It could be something as simple as answering 7 of 10 basic math arithmetic items. You might say, okay, if they get 7 out of 10, then they have mastered arithmetic. Another example of a criterion reference standard would be running a mile in under 4 minutes to qualify for a team. Something like carrying out an independent research and writing a dissertation to earn a degree, something we do at UMass and elsewhere, right? It doesn't matter if the student's dissertation is better than someone else's dissertation. It just matters that they have met the criterion of a good dissertation that we consider at UMass. So some examples of proficiency classifications based on criterion reference tests would be pass, fail, failing needs improvement, proficient, advanced, formerly used in Massachusetts. So these cut scores on the test that are used to put students into these different categories are obtained through the process known as standard setting. And in standard setting, we use subject matter experts to figure out what students at different levels actually can do, what they know, and then they set the standards based on what the test is measuring accordingly. So with respect to norm reference and criterion reference testing, to kind of just sum this up, in norm reference testing, we need a norm group that's appropriate for the students tested. The standards are very clear on that. In criterion reference testing, we need to make sure that the criterion domain is clearly defined. So each of these different approaches has some really critical elements that need to be in place. Now, as I mentioned, when I was growing up, the 20th century norm reference testings ruled the day. In the 21st century right now, most of what we're doing is criterion reference testing. Most, but not all. So that's important. Now, there are similarities we should talk about. They're both standardized tests, right? They could be administered in the same condition. It's for everybody, have the same content, be scored in the same way. They could measure similar areas of the same domain, math, 8th grade math, 6th grade social studies, whatever. The way we try and represent the domain with relevant and representative samples of items is the same. A lot of the same rules for item writings And when we evaluate the test with respect to criteria for reliability and validity that we'll talk about in a minute, there, we have the very similar standards. We expect reliable scores. We expect the use of the test scores to be valid. We expect validity evidence for those uses. And both are used in educational assessments. Okay, so that was a quick lesson, probably too quick, on norm reference and criterion reference testing. So speaking of testing, I'm going to give you all a quick test. So I'll ask you some questions. I'll give you an example, and you'll tell me if the example represents a norm referenced example or a criterion referenced example. And you can type the answer into the chat, or you could just keep it in your head, and I'll give you the answer. So the first one is a pass on the Massachusetts teacher licensure test. So a teacher licensure test, is that norm referenced or criterion referenced? Correct answer is criterion referenced. It doesn't matter if you do better than other teacher candidates on the test. What matters is that you reach that standard of performance to pass, that criterion of performance, so criterion referenced. Next example, winning a gold medal in the 40-yard dash. If we think about that contest as a test, winning a gold medal, would that be criterion referenced or norm referenced? The gold medal doesn't matter how fast you did it, you just have to beat everybody else. So that would be norm referenced. You're being compared relative to everyone else. Third example, type 40 words per minute without error. That's also criterion reference because, again, you're not being compared to other people. You're being compared to that standard of performance, 40 words per minute with no errors. Next, a 5.1 grade equivalent score in math. It's an example I gave before. What does that mean, 5.1? 5.1 is the average score for a fifth grader during the first month of school, let's say September. So because we're talking about an average score, that is norm referenced. We're comparing to the norm. The norm is another word for average. Failing a driver's license test, again, doesn't matter how other people did, so that would be criterion referenced. Scoring in the top 5% of test takers on the SAT. Everybody wants to be in the top 5%, right? Problem is, not everybody can. Quick math question. What percent of people could be in the top 5%? So obviously that's norm reference because we're now referencing someone's performance with respect to the whole distribution, the percentile. So anytime you see a percentile or a grade equivalent score, you know you're in the world of norm reference testing. Advanced placement exam. Got scores of 1, 2, 3, 4, and 5. Does it matter how other people did? When you get that score, no, it doesn't. So that is another example of a criterion reference test. So hopefully these examples kind of give you an idea of the differences between norm reference and criterion reference testing, and that's important to keep in mind. All right, next topic is reliability and validity, two very important concepts we need to talk about. And I put them together here as one word because many times people just talk about reliability and validity and say it really quick as if they're one thing, but they're not, they're different. So they're often described as the most important concepts in testing, and they certainly are very important. So let's start with reliability. A good synonym for reliability is consistency. So reliability refers to the consistency of a score we assign to a test taker. So questions like, are scores free from measurement error? Would a score for a student change if we asked a different set of questions or if a different person scored the test? If the answer to that is yes, then we have a lack of reliability. So reliability is really referring to, would we get the same result if we tested someone over and over again? My bathroom scale is unfortunately very reliable. When I step on it, I get my weight. When I step off and step on it again, I'm really hoping to get a different weight. I'm hoping to get a lower reading, but I get the same reading. So the scale is very reliable. So the idea in educational testing is that scores should not bounce around based on who scored the assessment or the particular test form I took or other context-dependent factors like, what's the particular reading passage. So we want test scores that will be consistent. We don't want a student's score to be influenced by something just related to the measurement procedure that's going to introduce inconsistency. So reliability is this difficult theoretical concept because basically we're saying if we tested a student over and over and over again, would we get the same score? If we test them, then when we erase that testing experience from their memory, test them again so we have no practice effect. We do this lots and lots of times, and then we take the average of all those scores, and that's our best estimate of their true score. So it's kind of theoretical because we're not going to test students over and over again. We might test them twice to get a test-retest reliability, for example. But we do need to get some idea of how much consistency in scoring the test has. So we do want to estimate the reliability of test scores. Now, it's important to note an unfair test can produce reliable scores. So we could say we're going to select people for a gifted program in mathematics based on their reading scores. That would be unfair. It would be invalid because we're measuring reading to place someone into math. But if we tested them over and over again on the reading test, we'd get very similar scores. So the reading test scores would be reliable, but not valid for the purpose of placement in that math test. The reverse is not true, though. If we have a test that we considered fair, so it's valid for its purpose, then the scores can't be bouncing around. They can't be unreliable. So it's just some basic ideas of what reliability is. We want consistency in scoring, but if we have consistency in scoring, it doesn't mean we're actually scoring the right thing. So reliability is necessary, but not sufficient for quality in testing. So if you look in a test manual or you start to think about, well, how can we evaluate a test? There are numerical estimates for how much reliability we think are contained in test scores. So you might see indices of reliability called like test-retest reliability or parallel forms reliability or internal consistency reliability. The latter would be something like a coefficient alpha, right? So a test-retest reliability, that's probably the easiest way to think about an index of consistency, right? We test someone twice. We look at the correlation of those scores, not someone, we test a group of people twice. We look at the correlation across those two testing occasions, and that gives us some idea of the consistency of the score. Did students get roughly the same score the second time as they did the first time? The correlation between those two testing occasions is called the test-retest reliability coefficient. Parallel forms reliability is very similar. It's just that we're not giving them the same form. So we give people two different test forms and we calculate the correlation between the scores on the two forms. Internal consistency is the most common because this is a way we can estimate the reliability of scores by just administering a test once. It originated by people saying, well, we don't have time to or the resources to test people twice. So let's administer a test once and then create two half-test scores for people based on maybe the first 25 items they took and the second 25 items they took. And then let's correlate those two half-test scores. That's one way of thinking about internal consistency reliability. And Cronbach and some others came up with a way of kind of getting the average of the correlations of all the different ways you would split the tests. And that's basically what coefficient alpha is. So that might not be clear, but it's a long way of saying that if a test is consistent in what it's measuring, then all the items on the test are kind of measuring the same thing. So the degree to which these items correlate with one another means that the students are performing in an internally consistent way as they go through the test. So I won't show any of the numbers here, but these are three different ways that we gauge numerically the reliability of test scores. To give you just a little bit of theory, we've got a simple arithmetic equation here, x equals t plus e. X is the test score for a student. That's what we observe. T is the true score for the student. We know that the test is not going to give us the true score, the actual performance of the student, because there's some error. There's some error. Maybe there were some test questions that the student misread or mismarked. Maybe the student was not paying particular attention or whatever. So anytime we have a measure of something, we have error associated with it. So X is the actual measure, T is the truth that we don't know, and then E is the error. So what we observe is partially truth and partially error. And the smaller the error is, the greater the reliability is. What this comes from is classical test theory. Now, we can make things a little scarier by squaring things and putting subscripts on it. But if you look at the S squared sub X here, we still have the X and the T and the E. So you see that it's like the X still equals T plus E, but the S squared refers to all the variation in the X scores. So we take all the student scores and we look at that variation. All that variation is composed of variation due to the student's true scores and the variation due to the error associated with those scores. So what you see in the bottom box is a reliability coefficient. Reliability equals the amount of the true variation that is part of the total variation. So the denominator of that equation is the equation that you see above. It's all the variation. And the numerator is the part that we really care about, the part that doesn't have any error. So for this reason, this is why reliability coefficients vary between 0 and 1. This is a proportion. So if all of the variance in students' observed test scores is due to the true score variance, we have no error, then we've got the same number on the top and the same number on the bottom. The reliability coefficient is 1. So the closer the reliability coefficient goes to 1, the less error we have, the more true score variance we have, and the more reliability we have. So reliability estimates are used to help us evaluate a particular test. If you're a teacher or a school administrator or someone working in a state or district, and you see that a test has a reliability estimate of like 0.5, you're not going to want to use it. The closer you get to 0.8, 0.9, the happier you're going to be with that. So reliability estimates are really measures that gauge something about the test scores. More is better. But reliability estimates don't give us information about a particular student's test score. We use reliability to estimate a standard error of measurement for students, and this is what's used to create an error bar around a student's test score. So if you ever see something like a student scored 250 on this test with a margin of error of 10 points, so we'd expect, if a student retested to score between 240 and 260. That's based on the standard error of measurement. So I just skipped the equation for that there. But what the standard error of measurement is an estimate of the amount of error expected in a particular score. So getting back to the concept of a true score, instead of saying, here's a student's score, we're going to use the standard error of measurement to give an interval within which a student's true score is likely to be. So we want it to be low. So for example, and this example comes from my colleague, April Zaniski. Let's say there's a student who has a score of 420 on a test. And the standard error of measurement is 19. If we subtract 19 from that score, we go down to 401. If we add 19 to that score, we go to 439. So the student's margin of error based on the standard error of measurement goes from 401 to 439. If we wanted to go 2 standard errors of measurement, then the margin of error gets larger. Typically, we don't go that far. But if we really wanted to say, well, where's the student's true score likely to be? Let's go 2 standard errors of measurement out. That's a lot. The student's score would be between 382 and 458 in this example. And if the standard error of measurement is larger, then those intervals get larger. So I'm going through this a little quickly because I want to get to some other concepts. Many tests today are developed with item response theory. So the concept of reliability is replaced by test information, which looks something like this. This picture comes from the Massachusetts Adult Proficiency Test. We've got, these are information curves. You want them to be as high as possible. And there's formulas we could relate based on the characteristics of a test to say at 30, this is a reliability of about 0.9. So each of these curves that represents a test seems to have a lot of information, which is similar to reliability. We're not going to talk about IRT much today because this is kind of a basic workshop. But IRT allows us to get an estimate of error for each particular student. So whereas the standard error of measurement kind of applies to one test. So if you add or subtract the standard error, it's the same for everybody. When IRT, each student gets a margin of error. And what we could see here, here's like a total, the test score along the horizontal axis here. And we're saying that most of the error for students along most of the proficiency range, the total test score range, is like 0.2 or less. But at the lower end, there's a lot more error. So IRT allows us to look at measurement precision or lack of reliability in a more fine-tuned way than a classical test theory approach would be. So those of you looking in technical manuals for state testing programs, they're all using IRT. And one of the ways they're going to show how well the test measures is through like some graphs like this. Before we leave the concept of reliability, when we were talking about criterion-referenced tests, we talked about classifying students into achievement levels. So the reliability of the total score doesn't matter as much as what's the reliability of that decision. If we tested them again, would they be in the same proficiency level? If we have a test that's pass or fail, if somebody passed, if we tested them again, would they pass? If somebody failed, if we tested them again, would they fail? So those are we're interested in the reliability of those classification decisions. And those reliability estimates are called decision consistency or decision accuracy. So it's important to keep those in mind and to look for estimates of decision consistency and decision accuracy if you're in the situation where you're making classification decisions about students. Okay, that was reliability in 5 minutes. Let's see if we can do validity in 5 minutes. So here are some validity questions. How do you know if a test is any good? Is it fair? Is it good as it can be? Is it appropriate for what you want to use it for? And what does this test measure? So the standards for psych testing describe validity as the degree to which evidence and theory support the interpretations of test scores for proposed uses of tests. Now, this single sentence contains a lot. The most important part is the last part, for proposed uses of tests. It's not that tests are valid inherently or invalid inherently. It depends what we're using them for. And the standards are very clear on that. So what is the theory on which the test is based? Does that make sense given what we're using it for? And by the way, do we have any evidence that it's appropriate to use the test for that purpose? So to make a conclusion, validity is actually a decision that the test is valid for a particular purpose. We need evidence and we need theory to support that use. So validity is not a property of a test. It refers to the scores and it must be evaluated with respect to a specific testing purpose. If that's the only thing you take away from the workshop today, then I'll be happy. Just remember that validity depends on what a test is being used for. And what we're trying to validate is the use of a test for a particular purpose, not the test itself. And if we're going to evaluate the validity of test scores, we need multiple types of evidence, different sources of evidence. In the 20th century, they were categorized as content validity, criterion-related validity, and construct validity, but that's changed. We now have 5 sources of validity evidence that are described in the standards for educational and psychological testing. The most recent version of these standards is 2014, but these 5 sources of evidence go all the way, they're 30 years old. They go back to 1999. Let me run through them. Validity evidence based on test content. It is just fundamental for educational tests. We need to make sure the content is right. And we typically use subject matter experts to evaluate that. So think about alignment studies. Alignment studies are the items on the test aligned with the curriculum frameworks. That fundamental question is a way we get validity evidence based on test content. So if you don't have people outside of the test developers look at the items and talk about how relevant they are and how representative they are, then you don't have evidence that their content is appropriate. Validity evidence based on response processes is really trying to ask about the cognitive processes students bring to the test. If a test is designed to measure higher level skills, if it's designed to measure scientific investigation, for example, is there evidence that it is? So if a test is administered on computer, we can kind of track what students are doing. We can interview students after they took the test. What did they do? We can ask them to think aloud while they're answering items. All of these studies, and again, and we're talking about gathering evidence, gathering data to evaluate whether the test is actually measuring what we think it's measuring. These are very important studies. They're hard to do, but they're important. Validity evidence based on internal structure is what you see a lot of. So these are things like looking at dimensionality of the test and factor analysis and so forth. And the reason you see a lot of validity evidence in this area is we don't have to gather anything other than test scores. Once we administer the test, these analyses are based on the students' responses to the items. Now, I would love to talk more to you about dimensionality analyses and residual analyses and all sorts of stuff that gets me and many other psychometricians excited, but that's not a fundamental concept, and we don't have the hours and hours we need to do it. But things like decision consistency or measurement precision, dimensionality, and so forth would fall into that category. Validity evidence based on relations to other variables would be how do test scores relate to other measures of the same thing? So if we have a math test in fifth grade in Northampton schools, how well do those scores relate to, how consistent are they with the grades students in fifth grade classes in Northampton are getting from their teachers? So if we correlate the grades and the test scores, that would be some validity evidence based on the relation of the test scores to another variable. How well does the SAT and ACT relate to grades in college, for example? So all these types of studies are examples of gathering data that would speak to the validity of the use of the tests for that purpose. Finally, we have validity evidence based on testing consequences. So all tests are supposed to have consequences. They're supposed to measure students' learning. They're supposed to protect the public in the case of licensure exams and so forth. So let's look at those consequences, but we also want to look at negative consequences that we didn't anticipate. So things like adverse impact, things like dropout rates, all these things we want to look at. And you've got a couple of references here. Suzanne Lane has a nice article in Psychothema about gathering evidence based on testing consequences. And also the Smarter Balanced Technical Report, I think, does a good job of getting into that area. Just a quick question. If you think about the U.S. Department of Education's peer review guidance, they've got 4 of the 5 sources of validity evidence listed that they're looking for. Do you want to guess the one they don't? It's validity evidence based on testing consequences, which I hope they fix in the next version. Construct validity is kind of an older notion, but I just want to say that construct is the thing that we're measuring on a test. So if we say a test is measuring mathematics proficiency is the construct. So it's kind of a more theoretical, older notion that is good to keep in mind. But when we think about, well, what is the standard saying about validity? The standards have adopted an argument-based approach to validation. Now, I don't mean argument like a shouting match, but rather building an argument based on evidence that the test is appropriate for its purpose. So the idea is to do these different studies where we gather validity evidence based on content and response processes and so forth, and then pull those different studies together in a way that demonstrates, that justifies the test is useful for that purpose. So just to kind of wrap up understanding validity, it's something that validation never ends. We're always evaluating test scores. And we want to make sure that any decisions based on test scores are reasonable, are reliable, and are valid. Running out of time, something related to validity is fairness. So I raised the question, does valid mean fair? Well, if we look at the standards, here's what the standards say about validity. We saw this before. Validity refers to the degree to which evidence and theory support the interpretations of test scores for their uses. And with respect to fairness, the standards say fairness means we're measuring the same construct for everybody, and the scores have the same meaning for everybody. So a fair test is not going to advantage or disadvantage individuals because of characteristics. So they're not the same thing. We need validity to have fairness, but they're not equal. So the standards, I'll refer to the standards for the different ways they describe fairness: fairness during testing, fairness as a lack of bias, fairness in access to the construct measured. So here we get into things about test accommodations, for example, and fairness with respect to validity of the interpretations and uses. One important fairness issue that's near and dear to all of our hearts in K-12 education is opportunity to learn. We have to make sure that before we start testing students, they've had the opportunity to learn the material. Another important fairness issue is removing any barriers due to testing conditions that might hinder some students. So do students need a separate testing room? Do they need some screen reading software because of a reading disability and so forth? These are all important issues that support fairness. Oh my gosh, I know I was going quickly, but we covered a lot today. So we're starting to wind down. Thank you for your patience. I hope I wasn't going too fast. When we post the video, we'll do it in half speed maybe. And I hate to introduce a new term, but I'm going to introduce two terms because they kind of summarize something about the problems that could come up in educational testing. So it comes from one of my favorite validity theorists, that's Sam Messick. And what he says is tests are imperfect. And they're imperfect in two ways. One, we could either leave something out that should be included. You know, we're not measuring important aspects of science or math or social studies or whatever. Or we're measuring something that should be left out, or both. So the terms are construct underrepresentation. The tests are not fully representing what we're trying to measure. So the criticism that tests are just measuring unimportant skills or narrowing the curriculum means they're not fully representing what we're trying to measure. The other thing is construct irrelevant variance. The tests are measuring students' ability to take tests. They're measuring test wiseness, or computer-based tests are measuring in part students' ability to work the computer. So concerns about construct underrepresentation or construct irrelevant variance, although those sound like technical terms, and they are, they're really important to us because we want to evaluate both. We want to make sure we do represent the construct, and I say we as in test developers, and we want to make sure we're not measuring stuff that's not there. So all the things we do to make sure we're not advantaging certain groups or have culturally inappropriate things there, or just measuring a dominant culture, or measuring computer proficiency are huge concerns. At the same time, we want to make sure we are measuring, you know, data analysis, number relations, statistics, probability, whatever it is we're supposed to be measuring. So thank you for making it all the way to the end. I hope you enjoyed our first 1 hour workshop. Here's my email. If you'd like to contact me about anything, or say, Steve, I wish, you know, we said more about this, or even have an idea. Steve, you know, you didn't include this, and I think it would be great for NCME to do that. But also to remind you that tomorrow we have Vince Vergis from Florida Department of Ed is going to give part 2 of this. Excuse me. And Art Thacker on Wednesday will give part 3. So also, if you're not a member of NCME, join it. It's a bargain, $95 a year. You get 2 journals. You get to collaborate with all of us. You get to join the special interest group of state and local assessment leaders. And just as a reminder, tomorrow we should have a bit more interaction. So it'll be the same bat time, the same bat channel tomorrow. So thank you for your attention, and I look forward to continuing the conversation tomorrow. Thanks, everybody. Bye.